So in this session I will explain problems on short circuit parameters. So this is the first problem. So for a two-port network, the results are obtained like this. Test results. Port 2 short circuited. Whenever port 2 is short circuited, these are the results. Whenever port 1 is short circuited, these are the results. I need to find these Y parameters. So the solution. So there is a two-port network. It is a two-port network. So for this two-port network, it is plus and minus, it is V1, I1, it is V2, I2, it is 1, 1 dash, 2, 2 dash. If port 2 is short circuited, that means V2 should be equal to 0. Then V1 value is this one, I1 value is this one, and I2 value is this one. Port 1 is short circuited, that means V1 is short circuited, that means V1 is equal to 0. V2 is equal to this much, I2 is equal to this one, I1 is equal to this one. I need to find the Y parameters. So the Y parameters, I can define these Y parameters. Y11 is equal to, it is I1 by, what is that, I1 by V1 whenever V2 is equal to 0, and Y21 is equal to, it is I2 by V1 at V2 is equal to 0. That means V2 is equal to 0 means port 2 is short circuited. So port 2 is short circuited, the value of V1 here is this one, I1 is this one. So I can calculate this Y11 as, so I1 is 2.1 at an angle minus 30 degrees divided by V1 is 50 at an angle 0 degrees. Next, Y21 is equal to, I2 value is, whenever V2 is 0, this I2 is minus 1.1 at an angle minus 20 degrees divided by V1 is this one, 50 at an angle 0 degrees. So if I calculate this value, then I will get, it is 0.042 at an angle minus 30, and the units for this admittance parameters are mhos, and Y21 is equal to, if I calculate this value, it will become minus 0.022 at an angle minus 20 degrees. It is also in mhos. It is Y11. Next, Y12 is equal to, it is I1 divided by V2 at V1 is equal to 0, and Y22 is equal to I2 divided by V2 at V1 is equal to 0. So I1 value, whenever V1 is equal to 0 means port 1 short circuited. The value of I1 here is minus 1.1 at an angle minus 20 degrees divided by V2 value is 50 at an angle 0 degrees. So it is Y12. And the same value I calculated here, that is this value is minus 0.022 at an angle minus 20 degrees mhos. It is Y12. It is Y11. It is Y21. It is Y12. Next, this Y22 is equal to I2 value, whenever V1 is equal to 0, I2 value is 3 at an angle minus 15 degrees divided by V2 value 50 at an angle 0 degrees. So if I calculate this 3 by 50, then it is 0.06 at an angle minus 15 degrees mhos. So these are the values of Y11, Y12 and Y21. So if I write all these admittance parameters in a matrix form, Y11, Y12, Y21, Y22 is equal to y11 is 0.042 at an angle minus 30 degrees. y12 is minus 0.022 at an angle minus 20 degrees. y21, this is minus 0.022 at an angle minus 20 degrees. y22 0.06 at an angle minus 15 degrees. So this is how we can solve this type of problems. Next problem here, this is the problem. It is a network for which I need to calculate these short circuit parameters or Y parameters. So whenever these type of networks are there, then how to find these Y parameters. So these Y parameters, y11 is equal to I1 by V1 whenever V2 is equal to 0, y21 is equal to I2 by V1 at V2 is equal to 0, and y12 is equal to I1 by V2 at V1 is equal to 0, y22 is equal to I2 by V2 at V1 is equal to 0. So if I use the let me use here this nodal analysis. Let me draw this same circuit here and apply the nodal analysis to find these Y parameters. Okay, this is plus and minus, it is V1, it is plus and minus, it is V2, and this is I1, it is I2, and this is node 2. Now the voltage at this point is V2, so this voltage is V2, and this is node 3. I am assuming that, so let this voltage, let us assume it is V3. It is 2 ohms, 1 ohm, 2 ohms, 4 ohms. If I use the nodal analysis at node 3 and node 2, so first at node 3, I am assuming that it is third node as given in the problem itself. So it is KCL plus Ohm's law is the nodal analysis. KCL is this current, sum of the currents at this point, algebraic sum of the currents at this point, at a point is equal to 0, or sum of the entering currents is equal to sum of the leaving currents. I am using this sum of the entering current as I1, that should be equal to leaving currents. This is one current and it is another current. If the current goes like this, this potential is more than that of this potential. So this voltage from here to here, or the voltage across this 2 ohm resistor is V3 minus V2, and the current that is flowing through this 2 ohm resistor is V3 minus V2 divided by 2 ohms. So it is V3 minus V2 divided by 2 ohms plus this current is the voltage across this 2 ohm resistor is V3, and the current that is flowing through this is V3 by 2. So V3 by 2. So if I write this, rewrite this expression, it is minus V2 by 2 plus V3. It is V3 by 2 plus V3 by 2. So it is V3. So let me consider this equation as 1. Next, if I apply the nodal analysis at node 2, this current I2 is equal to sum of the entering currents is equal to now sum of the leaving currents. Now I am assuming that the current is flowing in this direction. If the current flows in this direction, then this V2 is higher than that of this V3. Then only the current passes in this direction. Now this current, if you want to find this current, I need to find the voltage across this element. The voltage across this element is V2 minus V3, because the current is flowing like this. So this voltage is more than that of this voltage. So V2 minus V3 divided by 2 is the current flowing through this 2 ohm resistor. So it is V2 minus V3 divided by 2. Now this current is V2 by 4. So if I rewrite this expression, V2, if I take V2 as a common, it is 1 by 2 plus 1 by 4 minus V3 by 2. It is I2, and this is equal to, so it is 3 by 4. If I multiply with 2 and divide with the 2, it is 2 plus 1, it is 3. So it is 3 by 4 into V2 minus V3 by 2, that is equal to I2. It is equation number 2. So to find this Y11, it should be I1 by V1 at V2 is equal to 0. Any value, it is I1 by V2, I2 by V1, I2 by V2. There is no term of this V3 here. There is no variable of V3 here. So I need to replace this V3 in terms of V2, V1 and I1 and I2. So for that, I need to use one expression here. What that expression here is, this current I1 is equal to, this current is going in this direction, V1 minus V3. It is the potential difference across this 1 ohm resistor is V1 minus V3. So I1 is equal to the voltage, the potential difference across this element divided by the resistance offered by this element. So V1 minus V3 divided by 1 will gives the value of I1. So I1 is equal to V1 minus V3 divided by 1 ohm from the circuit. So I1 is equal to V1 minus V3. So if I substitute this I1 is equal to V1 minus V3 in this expression 1, equation 1, that means from equations 1 and 3, V1 minus V3 is equal to minus V2 by 2 plus V3. So 2V3 is equal to, if I bring this term to the left hand side, V2 by 2. So V3 is equal to V1 by 2 plus V2 by 4. So it is equation number 4. Now replace this V3 with this fourth equation. Here also replace this V3 with this fourth equation, so that these equations will come in terms of I1, V1, V2 and I2. So let me write that equation here. So I1 is equal to minus V2 by 2 plus V3. V3 value here is, this is the V3, that is V1 by 2 plus V2 by 4. So now it is, if I take V1 by 2 plus V2, if I take as a common, it is 1 by 4 minus 1 by 2. So it is minus 1 by 4 it is. So V1 by 2 minus V2 by 4. 2, that is 2 by 4 it is. So 1 minus 2 is minus 1 by 4. So it is V2 by 4. So this is I1. So let me take this expression as equation as 5. Next, so it is from equation, this is from equations 1 and 4. It is 1 and 4. Now from equations 2 and 4, from equations 2 and 4, I can write this equation 2, I2 is equal to 3 by 4 into V2 minus 1 by 2 into V3. In place of V3, I am going to write this V1 by 2 plus V2 by 4. So I can write it as 3 by 4 into V2 minus V1 by 4 minus V2 by 8. V2 by 8. So this is, if I multiply with 6 by 8 V2 minus V2 by 8 minus V1 by 4, this one. So it is I2. that is equal to 5 by 8 into V2 minus V1 by 4. So this is I2. So let us represent this as equation number 6. What I need to find here is, I need to find this y11. So y11, now this y11 can be calculated as I1 by V1 at V2 is equal to 0. So if I substitute V2 is equal to 0 in this expression, what I got here is, so I1 by V1 is equal to 1 by 2. It is from equation 5. So y11 value is 1 by 2. Next, this y21 is equal to, it is I2 by V1 when V2 is equal to 0. So I am using this expression now because it is I2 by V1 when V2 is equal to 0. It is minus 1 by 4. It is from equation 6. Now y12 is equal to I1 by V2 and V1 is equal to 0. So this is the I1 expression. So if I substitute V1 is equal to 0 here, so I1 by V2 is equal to minus 1 by 4. It is from equation 5. Next, y22 is equal to I2 by V2 at V1 is equal to 0. Using this expression here, by placing V1 is equal to 0, I2 by V2 is equal to 5 by 8. So it is from equation 6. So if I write these short circuit parameters in a vector matrix form, y11, y12, y21, y22, that is equal to, it is 1 by 2, it is minus 1 by 4, it is minus 1 by 4, it is 5 by 8. And here in this problem itself, he is asked to find and also determine whether the network is symmetrical and reciprocal. So what is the condition for symmetrical? So the condition for symmetrical networks in terms of y parameters is y11 is equal to y22, and the condition for reciprocal networks in terms of y parameters are y12 is equal to y21. So we derived these expressions just before this class. So here this y11 is 1 by 2, y22 is 5 by 8. So for this network y11 is not equal to y22. So this network is not symmetrical, and y12 is equal to y21. So this network is reciprocal. So the given network is reciprocal but not symmetrical. Now this is the another problem. For this I need to find the short circuit parameters. The procedure is same. Just now we solved the problem. The procedure is same. So what the procedure? We need to assume that this voltage is V3 and this voltage is V2. Before going to proceed to use that same procedure, first we need to convert this time domain network into frequency domain network or this S domain network. So this S domain network or the transformed network. It is also called as transformed network. This is resistance, this is capacitance, and this is the second port, port 2, is port 1, and this is V1, it is I1, this is 1 ohms, and this is 1 by Cs. 1 by Cs means 1 by C value here is 1, so it is 1 by S. It is also 1 by S. This value is 1 ohm, and this is plus and minus, it is V2. This is I2, and this voltage at this point, let us assume it as V3. This voltage is as this voltage, and this voltage both are same here, so it is V2. Now use the same procedure here at node 3. At node 3, apply the KCL or nodal analysis. So this current I1 is equal to this current plus this current. So this current is V3 divided by 1 by S, plus this current is V3 minus V2 divided by 1. So it is I1 is equal to, if I take V3 common here, V3 into 1 S plus 1 minus V2. Let us consider this equation as 1. Now at node 2, now I2 is equal to, this current is equal to this current plus this current. So this current is V2 divided by 1 by S, and plus this current is V2 minus V3 divided by 1. So I2 is equal to, if I take V2 common here, it is S plus 1 minus V3. This is equation number 2. Now from the circuit, this I1 is equal to, this current I1 is equal to the potential difference V1 minus V3 divided by 1. So V1 minus V3 divided by 1 here. So let us consider this is equation number 3. So from equations 1 and 3, from equations 1 and 3, if I substitute, it is V1 minus V3 is equal to V3 into S plus 1 minus V2. So why I need to equate all these things, why I am doing all this procedure here is, I need to get the equations in terms of I1, I2, V1 and V2 only, but not this V3. Okay, so I should replace this V3 in terms of V1 and V2. Because of that reason only I am equating this expression with this equation. Now it is V3, if I bring this V3 to that side, it is S plus 2. It is equal to V1 plus V2. So V3 is equal to 1 by S plus 2 into, it is V1 plus V2. Let us consider this one as equation number 4. Now from equation 1 and 4, from equations 1 and 4, from equations 1 and 4, I can write this is 1. So I1 is equal to V3, it is 1 by S plus 2 into V1 plus V2 into S plus 1. It is V3 into S plus 1 minus V2. So if I separate this V1 and V2 parts here, it is V1 into S plus 1 divided by S plus 2. It is V1 coefficient plus V2. If I take this V2, it is S plus 1 divided by S plus 2 minus 1. Now it is S plus 1 divided by S plus 2 into V1 plus S plus 1 minus S plus 2. It is minus 1. So that is minus V2 divided by S plus 2. So this is I1. Let us consider this as equation number 5. Now another equation. From equations 2 and 4, from equations 2 and 4, I will write this I2 is equal to V2 into S plus 1 minus V3 is this one, this 1 by S plus 2 into V1 plus V2. So if I write this, if I separate this V1 and V2 parts here, it is minus 1 by S plus 2 into V1 plus, if I take V2 as a common, it is S plus 1 minus 1 by S plus 2. So this is the this parts will be separated like this. It is minus 1 by S plus 2 into V1 plus V2 into S square plus 3S plus 2 minus 1 divided by S plus 2. So it is equal to minus 1 by S plus 2 into V1 plus V2 into S square plus 3S plus 1 divided by S plus 2. So this is I2. Let us consider this equation as 6. Now from the definitions of this Y11, these are admittance parameters, I1 by V1 at V2 is equal to 0, Y12 or Y21 is equal to I2 by V1 at V2 is equal to 0. So if I substitute this V2 is equal to 0 in this fifth equation, and then I1 by V1, from this I1 divided by V1 is equal to S plus 1 divided by S plus 2. It is Y11. It is from equation 5. Next, Y21 is equal to I2 by V1. I need to use this expression by making this V2 is equal to 0. It is minus 1 by S plus 1 from equation 6. Next, Y12 is equal to I1